Okay, this is the last unit of the course. We're going to look at logarithmic functions. There's actually two little lessons today, and they're both really short ones. I suppose you want to spread them over 2 days, you could. My suggestion at this point, because we're getting close to the end here, is you want to zip through these ones as quick as you can. So I would suggest doing 2 lessons today just so you can get through the first two. They're both pretty short. They might take you 20 minutes each, and then you'll be done. Okay, the first one we're going to talk about what is a logarithmic function. Before we can start using it, we kind of need to know something about it. So we're going to graph some things today and figure out some properties and some ideas on what things look like based on these graphs. So this is sort of like an investigation. Let's go through it together though. So we're going to make a table of values, x values from -3 to +3. So x, y. My x's are going to be -2 all the way, sorry, -3 up to +3. And to figure out the y's, we're going to use our equation y equals 2 to the power of x. So if we try 2 to the power of 3, you can use your calculator for this if you want to. You end up with 0.125. 2 to the power of -2, you end up with 0.25. 2 to the power of -1 is 0.5, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, and 8. And there's a pattern here, right? It's doubling each time. If I'm trying to sketch that, I'll start in the middle here, 0, 1, 1 and 2, 2 and 4. If I go the other way, it's a half, then a quarter, then an eighth, and a 16th. And it's so hard to see that it approaches that horizontal asymptote, the x-axis. So we know what's going to happen based on what we did last unit. Okay. That's an exponential function, an unknown exponent as our variable. Today we want to figure out something new about this. Okay, we're going to call it an inverse function. So the inverse of a function, in particular the one we're talking about down here, is found by interchanging the x and y values. Okay, so instead of y to the 2x, we end up with x equals 2 to the y. X and y have swapped spots. Okay. To graph this, we can do the same thing with our tables. We take x, we make it y, we take y and make it x. So the numbers aren't going to change, just the position of them. So instead of -3 and 0.125, well, this side has the 0.125, and this will have the -3. We've swapped positions. And then 0.25 and -2, 0.5 and -1, 1 and 0, 2 and 1, 4 and 2, 8 and 3, and so on and so on. Okay, they're swapping positions. If I graph that thing, which is what number 3 asks us to do, to graph it, okay, 0.125 and -3, that's really close to this y-axis and down here. Then 0.25 and -2, again really close to the y-axis down here. 0.5, 1 and 0, 2 and 1, 4 and 2, and end up with a graph that looks like that. Okay, so the red one was our original graph for exponential function, and the green one is this new graph. And part of number 3 asks, is this a function and how can you tell? And of course it's a function. And how do we tell? Well, the vertical line test, right? If I draw vertical lines for that function, and I know it's kind of hard to tell over here at the edge, but these points are actually separate from each other. It's getting closer and closer and closer. And if we could zoom in, we'd see that. That is definitely a function. Okay. Part 4 here, we want to graph the line y equals x on the same set of axes. We'll graph that out. My x and my y's have to be the same. So no matter what x's you pick, say we did these two, my y's would be exactly the same. X is y, y is x in this one. If I graph that, I end up with a line right here, 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 and so on down here. And if I try and draw a straight line here, it should be a straight line. And what do I notice with the red line compared to the green line? Well, they are a diagonal reflection. It has been flipped diagonally across that. So how do the graphs relate to this line? They are diagonal reflections across this line. Okay, I hope that makes sense so far. Okay, let's make a table based on the picture that you saw. So you look up above, I can flip back and forth. Okay, what is the domain of the original one? Well, this goes back to what we did last unit, exponential function. Domain should be all real numbers. What's the range? Well, we know it comes down to but never hits, 0. The x-intercept, didn't have any of those. The y-intercept, we had one of those, that's 0, 1, and it had an asymptote, yes. It was a horizontal one, and the equation of that was y equals 0. So let's take a look at this new function, the red one. Okay, what's its domain? How far left and right does this go? Oh, sorry, I did that backwards. We're now doing the green one, right? Sorry, that should have been green. Okay, we're looking at the green one. How far left and right does the green function go? Well, it gets closer and closer to the y-axis, but it doesn't seem to hit it. So the green one, okay, should be x has got to be greater than 0. The range, well, up and down, it seems to be going up and down forever and ever and ever. So this time it's going to be y is all real numbers. And yes, I know these colors are backwards. Okay, don't stress too much about that. The x-intercept of the green one is, it's right here, this dot. Okay, so 1, 0. Does it have a y-intercept? Doesn't look like it, right? It gets closer and closer to the x-axis, but never hits it. And does it have an asymptote? It sure does. It's a vertical asymptote. So its equation would be x equals 0. Okay, so there's some patterns here you might notice. And down the page here, we're going to start talking about some of these patterns. Okay, the equation, x equals 2y. We don't usually write things x equals. We usually write them as y equals. Okay, so we're going to change its form slightly. Every time we see this, we're going to actually think of y equals this. Log 2x. Okay, the 2 is my base. It goes down as a little number below the log. Okay, the thing on the left-hand side, the x, is a log of that x, and that comes out to y. And that seems a little confusing. We're going to do a few of these to get the hang of it. Okay, we call these logarithmic functions. Okay. Now, question 6 talks about how is the domain range of the function related to the domain range of the corresponding exponential function. Well, if you notice, if you go back here, these two things look similar, as do these two. These two look similar, as do these two. In fact, if you stop and think about it, they're kind of like opposites with one another. Okay, so the domain range of a log function, I'm just going to call them logs instead of logarithmic function, is the opposite of the corresponding exponential function, and vice versa. Okay, what do we know about the x and y intercepts? Same thing again. They're opposites. Okay, so one of them has a y-intercept, one has an x-intercept. And of course, be careful with the numbers, right? 0, 1, and 1, 0. They're in different positions. Okay. Okay, sketch graphs of y equals log 6 and its inverse on the same grid by making a table of values. So we need to make a table. Log 6. Now, me personally, I would find this hard to graph log 6x. But I know it's related to its other function. And how's the other function works? Well, the base is 6 to the power of x. And that comes out to y. Y equals 6 to the x. And that would be the inverse of this, the exponential version. And that's something that I can make a table for. And I can make a table for this one pretty quickly, actually. X and y. I'm going to just go to -2 this time. And if I try -2, 6 to the -2, I get a big long decimal or a fraction version, 1 over 36. 6 to the -1 would be 1 over 6. 6 to the 0 is 1. 6 to the 1 is 6. 6 to the 2 is 36. And I can graph that. Now remember, that's this function, right? So 0 and 1, 1 and 6, -1 and a 6. And it's going to start looking like this. That's my exponential function. If I want to do the log function, I swap my x's and y's. So I'm going to start with this column as the x, and this would be the y. So 136, oh, just really tiny, and -2. 1, 6, and -1. 1 and 0. 6, 6 and 1. So that function would look like that. And that would be the log version. It's hard to draw the log ones first. I would draw the exponential one first and then flip the order to draw the log things. Okay. It says to include the line y equals x to make sure it's a diagonal reflection. So let's do that. We know it's one that goes right up the middle here. And there's our diagonal reflection. It really looks like a diagonal reflection. Okay, the second one. It says graph y equals 4 to the x. Well, that's something we know how to graph, right? That's an exponential function, 4 to the x. I can make a table for that one real quick, x and y. If I'm going to use my calculator, 4 to the negative 2, that's a big long decimal, or 1/16. 4 to the negative 1 is 1/4. 4 to the 1 is 4. Sorry, 1, 4 to the 1 is 4, and 4 to the 2 is 16. I can graph that pretty easily. Negative 2, negative 1, 1, 3, 4. There's my picture. If I want to graph the inverse of that, I swap my positions. This becomes the x, this becomes the y. So 1/16 to negative 2, 1/4, 0, 1, 4, 2, 3, 4, and 1. And I end up with a function that goes up the side. What's that function called? A logarithmic function, right? And again, it says put the purple one on there. So I'll put the purple one on there, my diagonal line down the middle. Okay, so you're getting the hang of how this works a bit, I hope. Okay, part 8, write the equation of the inverse. Now, I kind of already did that a little bit, but just to practice it. Okay, the question was y equals log 6x. Okay, the inverse of that, my base is 6. 6 to the x equals y. And basically, if you think about it, this stuff all goes right there, right? Okay, the other one was y equals 4 to the x. Y equals 4 to the x. So my inverse will be log. The 4 goes down here, the x goes here, and the y is on that side. Okay, and that would be the inverse function of that thing. Okay, so far so good, hopefully. Okay, we're going to take a look at some properties now. And again, just practicing, recognizing some things. Oh, and some people wrote on my screen here. Okay, type of function. What is this function called? Well, this is a log function. Okay, what's the domain of a log function? They're always going to be greater than 0. The range, if you look at that one, y is all real numbers. The x-intercept, 1, 0. The y-intercept, there is none, and it has a vertical asymptote, and the vertical asymptote is always 0. And we can look back at the picture we want to and tell that. That would be the red picture, this one right here, right? That's what we're looking at. Its inverse, the green one, well, if we're smart about it, we know these things are opposites. So this one will be an exponential function. This one will be x is all real numbers up here. This one will be y is greater than 0. This one will be not applicable. This one will be 0, 1. Make sure we change the order there. And this one, the opposite of a vertical asymptote, is a horizontal asymptote. And the equation would be y equals 0. Okay. We'll do the last one real quick. Hey, what kind of function is this? This is an exponential function. Well, if we're cheating, it should be all the same information we just had down here, right? Okay, so x is all real numbers. Y is greater than 0. Not applicable. 0, 1. Horizontal asymptote. Y equals 0. Okay, if we try the last one, what is this? The inverse of an exponential would be a log. We can sort of cheat, right? Go back to the beginning one. Our domain should be all, greater than 0. Our range should be all real numbers. Our x-intercept should be 1, 0. There shouldn't be a y-intercept. And we should have a vertical asymptote of x equals 0. And we can confirm that with our pictures. Those properties are true for any log or exponential function. Unless we start moving them around, which we're not going to in this course. Okay, so that's the first part, part 1. Part 2, we're going to start talking about actually how to calculate some things with logs. We just had to get an idea what they look like first before we could do that. Okay, as I said, I would try the next lesson and try the homework that's based on that one. It should be pretty quick.